Okay, so we'll continue this video about objective 2. So we have two more questions to do that have to do with solving this type of equations. So one thing first we need to discuss is, as we see in fractions, and there is something you deal with in college algebra, which is of course functions and the domain and range and all that, which you will see more. This question comes at the end of intermediate algebra. So that's one thing to know. So before we start, we have division by zero is not is undefined. So this is something we need to always avoid. And to avoid that, we need to find out what makes the denominator zero. So if you look at this y plus 3, if y equal negative 3, so if you set it to 0, y equal negative 3 would make that 0. It would make it undefined. So negative 3 is not wanted as a solution. If you look at y plus 1, y plus 3, and you do the zero product property on it, you'll find out that when you set y plus 1 equals 0, you get y equal negative 1. When you set y plus 3 equals 0, you get y equal negative 3. So these two numbers are not desired here because they make this thing undefined. So before we start this type of problem, we should say a statement: whatever we do, y cannot be negative 1, and it cannot be and negative 3. Which means whatever you do, don't come at the end and say y is negative 1 and another number like 5 or something like that. That won't be correct. All right. So once we know that, we know what it shouldn't be, then we can go ahead and start. And in this case, we're going to use a common denominator because we have a lot of fractions, and we use a trick to simplify it. So let's rewrite. So these, if they're not, these denominators, if they're not factored, you factor them. And once you factor them, it makes it easier to know what you need. Let's maybe make this, give it some space. All right. So then from here, we're gonna try to make all the denominators the same for this type of equation. If we make all the denominators the same, there is a trick to simplify. So if you look at the right side, you have y plus 1 and y plus 3. If you look at this one on the left side, you have y plus 3. So if we have y plus 1 here, which means multiply up and down by y plus 1, we're going to have the same denominator of the here and here. And this one has only 1. So if we can have y plus 1 and y plus 3 here, right, then we're going to have same denominators for all these fractions. So let's write it just nice and neat so it's clear what we're trying to do. So pretty much we're making the denominators the same. So if they're not factors, you factor, and whatever is missing, whichever factor is missing, you're going to put it there, multiply up and down by it. All right. We know one thing: if I have a 2 minus a 5, then we can do this. We need a common denominator, right? But if you have, so this is a note on the side, but if we have a 2 minus something with the 2, you keep the denominator as a 2 and you do the top. Let's say this is a 7 and this is a 9. You're going to say 7 minus 9, which is negative 2 over 2. So same thing here. This denominator and this denominator are the same. Just like a 2 there, we're going to keep. And we're going to do the top part. Negative 5 times y plus 1. The first numerator minus the second numerator. And here is the right side. So I'm not solving yet. I'm just preparing it to simplify it. And there is a nice trick here, but to know it, I have to show you a small example for it. It applies to fractions. Let's say put here A, and this is A. You see this one and this one are the same? Let's put a 4 here. Just like here. So can we guess what should be on this one? Well, let's put instead a number. Let's put a 5. So can we guess what should be there? Now it's obvious it's 4, right? There is no way for this left fraction to equal this 4/5 here unless this here is 4. So for this A and A, if A is 5, we get this same example here. Then this must be 4. So if the denominators are the same, like in this case or this case here, right? Then the numerators are equal as well. So that's the trick that we're going to use to simplify this big thing. So we're not going to cross multiply, we're not going to distribute or anything. What we're going to say, since this is A, or we'll just say this is 5, this is 5. We don't know, but they're the same, they're equal. Then this one and this one are equal, all right? And that will help us move from something complicated a little bit to something doable. It's going to be a lot of multiplying and stuff. All right. So this form is much easier than what we had. As I mentioned, usually this question comes at the end of intermediate algebra and some beginning of college algebra, just like we are doing now. All right. So from here, we're just going to multiply, FOIL, distribute, and FOIL and all that. We can probably do FOIL first for these two, then distribute the -5, right? So maybe let's do that. So a y square, a 3y, a 1y, and a 3, and a 2y, and a -2 before. Then now a -5y squared, -15 y. Well, I could combine like terms or multiply either way. -5y, -15 minus 2y minus 2 equal 4, right? Let's make this maybe that one. All right, so anything to combine, we have -15 minus 5 is -20. Then we have -2, that's -22y. We have -15 and -2 is -17. And we have -5y squared. We're going to subtract this 4 to both sides. because we want that standard form, and it's going to be 21 equals 0. All right, so now you have something like ax squared plus bx plus c. If you don't like all these negative signs, for some reason you don't want to use them, you can multiply the whole thing by -1. So you distribute, that'll be a positive 5. I'm missing a y there. And a plus 21. So it's this one or this one, whichever. They're both equivalent. All right, let's use a quadratic formula on it. So y equal -22, 22 squared minus a 4 times a times a c all over 10, 2 times 5. All right, so let's go ahead and do these numbers. So we have a 22 squared minus 4 times 5 times 21, and a square root, that's going to be an 8 over 10. So the first one, -22 plus 8 over 10. The second one is -22 minus 8 over 10. All right, so the first one is a negative 14 over 10. And the second one is -30 over 10. This can be simplified, all right? So if you try it, all right, so we can go ahead and simplify. This one will give us a -3. And this by 2 should be a 7, and by 2 should be a 5. All right, so we have two solutions, and we're going to check, as I mentioned, with the domain. We started with the note of the domain. I'm not talking much about the domain because you haven't done the details about it, but for now, let's call it a restriction. All right, of the domain of the denominator. There is a restriction there. Cannot be -3. Since it cannot be -3, this is going to be rejected. So we reject -3 because y cannot equal to it based on what we started with. So the solution set is -7/5. And we can check it, of course, if you want to. You can check the solution. So you see the difficulty in this question is not only because the way it looks, it's in all the details and in the check as well. All right, so we have a similar question that we're going to solve here. You see this one is not factored, so we'll go ahead and factor it. So let's see. That's a difference of squares, so it's y plus 6 and y minus 6. And that's y minus 6. And similarly now to the previous one, anything that does not have a sum factor, we won't make all the denominators the same. And this one is the one that has a 2, so everybody here should be matching. So this, let's give this y plus 6. And this doesn't need anything, it has the 2. And this one needs 1 minus 5, minus 6, right? So based on the first one we did, that means the left side is right. And these two, like I said, since these two are the same, we keep the common denominator and we attempt to subtract these. Well, we're not subtracting yet, we just show what we're supposed to do. Then based on the first example, we say that if the denominators are equal, then the numerators are equal, right? So these are equal. Because it's not possible for these two to be equal unless the numerators are equal. So that simplifies y to y minus 6, y plus 30, y minus 3 times y plus 6. And we can go ahead and say y plus y plus 30 minus 3y, distribute minus 18, that's a negative 18 there, right? And y squared minus a 6y. Here you remove parentheses, just 1, so 1 times y is y, 1 times 30 is 30. Right? And y squared minus a 6y. Here you have a y and a 3y, so negative a 2y, right? What else? We have a 30 minus 18, it's a positive 12. We have y squared minus 6y. So we need to add the 2y to cancel from here and show up here. And we need to subtract a 12 from both sides to show up here and cancel from there. So you subtract 2, it's subtracted 2y, so you need to add 2y to both sides. And you need to subtract 12 to both sides to get this form. Then this one with this one is negative 4y. And here it does not have a 1, so we're not going to go ahead to use the quadratic formula because we want to see whether it factors or not. Since a is just 1, so it should be the product of here and the sum here. Two numbers you multiply in negative 12. So some numbers you multiply in negative 12, let's just say 12 first, without negative would be these, right? But their addition is 4, or their difference is 4. This doesn't have a 4. It's either a 7 if you add, or a 1 if you subtract, right? These have a 4 if you subtract. These don't. So now two numbers you multiply, you get negative 12. So one of them needs to be negative. Since this middle is negative, means the big one is negative. So it's negative 6. Let's just do it directly. Y minus 6 and y plus 2. This is a plus 2, right? So negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. Then we use the product property to set each one to 0. And you get y equals 6 and y equal negative 2. So now I did do what I did on the first one for a reason, because just to show that, you know, if you didn't talk about it first and look into the restriction and stuff, what's going to happen is, well, you know, we get excited, we found the solution, we don't think anything went wrong here, and we find the two numbers, then yeah, so you see a 6, it conflicts here. It makes this denominator 0. So if we remember that, we will fix it and get rid of it. But if we don't remember that, we're going to go ahead and claim that something is solution when it's not, right? So this is called the extraneous solution. Extraneous solution means an extra solution that shows up in the process because you have an equation that's not quadratic and it became quadratic, and this quadratic gives out 2, right? And so now we need to check. So that's a key, and that's one of the things you learn in math is you know, to check the decisions whether what you're actually providing is a solution or not. So if we do a check, we're going to reject. So we're going to reject this, and we're going to say the solution is -2, right? And 6, reject the 6 because it makes equation undefined. It does not solve it, it makes it undefined, right? All right, so I hope this clarifies this thing. So, and if you have questions, let me know. Thank you.